I start. So, hi. Today I will tell you about the project I've been working on the last few months, which is a KernelShark plugin for student trace analysis. I am Giuseppe Eletto. This is my first talk ever, and this project is part of my thesis for the University of Turin. I was being followed in development by Enrico Bini and Dario Faggioli from SUSE, who also is here today. So, before talking about the project itself, I want to introduce the two software used, which are KernelShark and Xen. But about this one, I will talk mainly about the tracing. Let's start. Well, Xen, KernelShark. KernelShark is a graphical interface for tracing D, developed by Steve Rustel, and starting with the version 2, which also been released last week, it implements a new plugin interface that allows the application to open a lot more file types than before. This is the screenshot of the main view. On top there is the timeline view, which is divided into by each call for and colored with plots of the event. And below we see the same events but listed. For example, we can see the physical core on which the event occurred, the time, so when it occurred, and the task and the PID, so the application that triggered that event, has some more information like the event name and the arguments. I say that KernelShark is the graphical interface for tracing D, but what is it, tracing D? Tracing D is this time a command line interface for ftrace. That is the most famous tracing framework for the Linux kernel, developed by Red Hat and introduced into kernel in version 2.6.8-RC2, so a few years ago. The main ftrace is mainly used to record the kernel and all its modules, including, for example, the system calls, kernel function, the user space function like a malloc, and some other events that a developer can insert into user space or kernel space. At this point, some of you could think, but what does have to do with hypervisor? Well, KernelShark is also widely used to debug KVM, which is a hypervisor like Xen, but is also a modular kernel. And because of that, it can be traced by ftrace, so it can be analyzed with KernelShark. I don't lie, the first thing I thought was, where is the problem? Let's make Xen a Linux module and I will have nothing to do. I found out that it's not that simple and it's not how Xen works. For the few people who may not know what Xen is, I spent just a few words. It is a type 1 hypervisor, originally developed as a research project for the University of Cambridge, and now has become a collaborative project of a Linux Foundation, which is also hosts the event today. Talking about the architecture, Xen works as a microkernel that sits directly over the hardware, and on top of it runs several virtual machines that we call domain, which the most important one is the control domain, the domain 0, because it's the only one that has special rights over the hypervisor and over all the other virtual machines. Talking about the tracing instead, it is done by a tool called XenTrace. It can be done just from the domain 0, because, as I said, it's the only domain that can communicate with the hypervisor, and generates a binary file consisting of records which are dependent on one another. Xen use, or better say, Xen developers choose to use different buffer to store the event records, and this allows the hypervisor to get rid of, for example, a system semaphore in order to schedule who should write into a single buffer. It will be Xentrace when you start a schedule section, a tracing section, to collect the record from the different buffers into a trace file. The problem of this file is that each event, as I wrote, is dependent from the previous one. So if you try to take a random event from the trace file and read it, you will not know, for example, on which CPU, physical CPU, it occurred, and you don't know on which domain or virtual CPU it occurred, because you have to read before the event that say that. Other thing you could not know is the timestamp, because some events doesn't have that one. Do not have one. Talking about the reading of a trace file, you can't open it with a simple text editor. This is because it is a binary file. So if you try to open it, you will see just a bunch of random characters that say nothing. But you have to know how an event record is formatted. We have the hidden, which is a 32-bit unsigned integer split into 28-bit, that for the event code. The next 3 bits are the size of the extra argument array that goes from 0 entries to 7 entries. And the last bit is used to check if the event include or not the timestamp, which is the value of the CPU cycle from the hypervisor setup. The other two fields are optional, based on what we read from the. Talking about the front end, so far there are just two of them for Xentrace, which are the first one, KernelShark. It is a powerful tool that analyzes trace by capturing a lot of information and generating different output based on what you want. For example, you can ask for a dump of each event in the trace file, or you can just want a summary of a domain. The other one is much simple, because it does just a one-on-one translation from binary to human readable text of each event you read from the trace file. The project. Well, it must be said that despite the excellent implementation that the KernelShark developer did, it remains closely tied to TraceCMD. In fact, we faced some challenge during development. For example, the fact that TraceCMD is based on process scheduling, while Xentrace used domain scheduling. And because of that, KernelShark was developed with the idea of analyzing trace that contains tasks and bits. As you saw in the screenshot before, there were the column of tasks and bits. So we added the parsing we did of the Xentrace files, and the task column became the task of the pair virtual CPU domain, and the PID column, which is also used to color the plots in the timeline view, became the same pair but in decimal value representation. Another problem that we found within that plugin is that the TraceCMD event code are written in 60-bit, and KernelShark use field-wide 60-bit to save event code, while Xentrace ones are written in 28-bit. Thankfully, KernelShark developed provide us a function that is called when the application asks for event code from a record. So we bypass this problem by simply saving the data in the plugin and getting it when it's required. Plugin is developed as two distinct components. The first is the parser that does the analysis of the trace, and it is a standalone library, so you can take it and use it in whatever project you want to. And the other one is the plugin itself that takes the parser output and fits it into KernelShark. So the analysis made by the parser works by taking 3 actions for each event you reads. First, it checks if the event marks a switch from one buffer to another. So it checks if the event is a pCPU change event. After, it does the same, but for the running domain and virtual CPU. So it checks if the event belongs to the family of scadmin events. And finally, it sets the timestamp of the event that do not have 1 to the last valid value read from the previous ones. So if an event does not have the bit that say that the event include a timestamp, it set that bit to 1 and copy the last timestamp into the event. This in order to make each event independently readable from one another. After that, we save all the records in a list of structs made as follows. We have the original record data from Xentrace, the one we said before. But there is also the CPU ID, the host CPU ID, and the pair virtual CPU and domain, which are used for the task column and the bit column in the KernelShark main view. The last thing that the parser does is to rearrange in chronological order the events record using the C standard library QSort algorithm and comparing their timestamp value. The plugin following the view model pattern is the dumb module because it does just 4 things. First, it requests the parser to load a trace. After, it notifies KernelShark of the number of events and CPUs to load. And the last thing it does is convert the timestamp value to second using the clock speed of the host machine and translating the event code and the extra information of an event to the human-readable text format. So we started with this project having KernelShark say that Xentrace file contains no data, and we end up with a KernelShark instance that actually managed to read it. Something more, the plugin has been released to Xen and KernelShark communities using the mail list, and there has been positive feedback, including from container of KernelShark. And our to-dos are enhancing the translation of events and the information, because so far it's just a bad copy-paste from the Xentrace format files. And next, we want to improve the plugin to support event synchronization between host and guest trace file in KernelShark.
Hey, hello everyone. This is Dario. As Giuseppe said, we worked on this together, or actually he did all the work. I guided him. So, do we have any questions? There's none in the chat. There is still time for quite a few in theory, I guess. Perhaps, Giuseppe, this is unplanned, so feel free to answer no. Do you have trace that you can open and
Yes.
show it like a small on-the-fly demo while we wait for questions, if any will come up?
I'll do it.
Great.
Open like that. We set the plugin and the trace file, and this is KernelShark that is.
Yeah, exactly. That's the cool thing of KernelShark. You can zoom in and try to figure out and learn at an arbitrary level of details what's going on. Well, arbitrary depends on the trace point that you have, but you can have like an overall picture as we are seeing right now, or zoom in quite a bit more and see what happens. Yeah, you will see fewer events, of course. And for the ones that are maybe not familiar with KernelShark, because as Giuseppe said, it's the main tool used for tracing on Linux. Okay, let's first answer the question, since there is one. Would it be possible to translate these traces to something like a pickup that could be analyzed in Wireshark? Well, everything is possible, I guess. I have no experience with Wireshark except for opening from time to time random network session traces when something is wrong in connectivity. The idea would be that you don't need it because you have KernelShark that now can open send traces, and it can also continue to open Linux traces, of course, and you can even open both accent traces and Linux traces, for example, from non-zero or from a guest. Also, right now they will be shown as completely independent, and you will see them completely apart because we are still missing the logic for synchronizing host and guest traces. This is something that is coming up in KVM environments, still with TraceMD and KernelShark, we don't have it on for Xen yet because we didn't even have the capability of opening the trace with KernelShark until before that Giuseppe started working on it. So that's what we are planning to do. Again, perhaps because I'm ignorant about everything that is not basic usage of Wireshark, I don't know what that could provide you, whether it would be more useful or better than something like this. Perhaps yes, but I have no idea, to be honest. Yeah, what I was saying before, basically what Giuseppe is showing right now is the classic look of KernelShark, where we see physical CPUs and in a Linux environment, we would see these colored blocks, which are tasks running on physical CPU. So if this would be a Linux trace, for example, there will be, it would tell us that there is a task running on CPU4, and basing on its speed, KernelShark choose the color light green. Now that KernelShark is being used for displaying send traces, what this is telling us is that there is a virtual CPU of a guest of a domain running on CPU4, which, yes, as Giuseppe is showing, is exactly, as a matter of fact, is domain 0 vCPU3. And when, yes, at that point, when the green block stops, basically beyond that point, there is nothing running on CPU4, and in fact the plot is just empty. And in fact, the event that we see right before the plot becoming empty, is the, well, runnable to running is basically domain 0 vCPU4 stopping being executed, and and the idle virtual CPUs starting being executed on CPU4 at that point. This is something that one can say that this is something that we had already on Xenalize, for example, which is the case indeed. But of course, Xenalize, you don't have these fancy graphical visualization capabilities, and there are a bunch of things that you can do because KernelShark can just do them, like, for example, being what they are called markers in correspondence of some events, and have the time difference between the markers and then between the two events automatically computed and displayed by KernelShark. And there are even further extensions that we can do to enhance this visualization, because KernelShark can be extended with more and more plugins, which is, of course, not there yet because this is the first piece of work. But I don't know if by Giuseppe, because this was his project for his bachelor degree thesis, which he has completed now, but I would love to see more development on these plugin or other plugins extending from this work. Yes, last 4 or actually probably 3 minutes. Can KernelShark be used to analyze in runtime or only snapshot? You want to answer, Giuseppe?
I think this option is only for ftrace, because we don't have an option that start tracing and of send and contemporary view the trace does.
Yeah, that's probably true.
We
so
we have just visualizing trace files running tracing section.
I think that KernelShark can start trace CMD, that you can start and stop, exactly, with the record interface. But at the moment, that's a perfect example of some further development that it would be really nice to happen. So KernelShark can start and stop tracing, but by default and right now, what you will get is that it will try to start and stop trace CMD, which will trace some Linux activity, for example, in DOM0 if you are running KernelShark in DOM0 or wherever you are running it. It would be interesting indeed to further extend KernelShark to be able to also, when we click record, start send trace instead than only trace MD. Yeah, no, but not because it's not possible, just because it's not there yet. Exactly, under construction. Well, hopefully, if there will be someone interested in continuing development. I plan to do some development myself, but fully not alone. One minute left. Actually, feel free to contact both of us and
Is on GitHub.
yes, me for if you are interested in continuing this work. Yeah, go ahead, Giuseppe, for the GitHub. I think you have the reference to the repositories in the slides.
Let know. I'll put it into the chat.
Okay. But yes, it's there. Hopefully, at some point, the code will be moved either in the Xen code base or the KernelShark code base. But we still have to decide where basically, depending on a few. Yeah, I think we are. Time is up, I think. Thanks everyone for attending, I guess, and for the questions. Yeah, bye.